well, if you really want to show an efficacy, a clinical efficacy, you have to use these models where you really wait till the animals get diseased before you start treating, instead of trying to treat them almost immediately and see for effects, because there you just look at specific processes that you are blocking instead of that you are blocking the disease. One of the things, and that's we are more and more looking into it now, what we see is, for instance, if you induce the disease, like now at the moment a hot topic is the B cell responses, where you have antibodies where they deplete the B cells to get improvement of the disease. What we see is actually in our models is that if you start inducing the disease in these animals, although you induce it for instance, myelin basic protein, in the end you see a lot of autoantibodies to all kinds of different brain antigens. So that means that the disease is spreading actually in the body. So you have to be really careful. So if you start treating almost at the start, you're only looking at this one thing. If you're treating at the end, then you're looking at a lot of processes that have been taking place, and that is actually what you're looking for in patients, because these are the patients you get into. You don't get a patient that comes in and says, I will get multiple sclerosis next week. You get them in that says, I have multiple sclerosis, and you have to treat it. So that's, so the big theme is, I don't say we have the golden eggs for multiple sclerosis. What I know is that we have a treatment here that is actually very, very powerful. But the general theme, I think, and that is more, is that we should start looking into how we call multiple sclerosis. Multiple sclerosis, I will not call an autoimmune disease. Multiple sclerosis is more a systemic disease where you have a lot of different components that are going wrong in these patients. And if you keep calling it an autoimmune or an inflammatory disease, you are probably missing the point. And it's actually, like they say in Denmark, it's a bjørnetjeneste. So you do not help the patients because you're focusing too much on one of these aspects of the disease instead of that you're focusing on the disease itself, which is much broader. And that's what we try to do in our research, is try to show that actually if you look at the disease itself, you have a lot of these different components that are all out of balance, and we have to get them back, and just screwing on one of them is not going to help you too much. It will help you some, but it will not help you in the end. So, If you look at the multiple sclerosis as a disease, you see the T cell responses, the B cell responses, the metabolomics, you see mitochondrial dysfunction, you see iron deposits in the brain, blood-brain barrier losage, you see rapid oxygen synthetase, so hydrogen peroxide production. All these things, they are a part of the disease, and in all of these different functions, you see lipid metabolism is involved in one way or the other, and therefore it's an interesting target, because it's so I don't say that just the lipid metabolism shift can give you the disease. What I say is probably something can give you an inducing part, and then the lipid metabolism comes on top and drives the disease forward, and so gives you the inflammatory response, gives you the T cells, gives you the B cells, gives you the iron deposits, gives you the hydrogen peroxide production and mitochondrial dysfunction. And so we have, and it could be one of the basic mechanisms or underlying things. And the only way to show it now, we have shown it in animal models, and now we have to go into human studies to show it also.